In this section, we're going to review the definitions of angle relationships, as well as look at some examples of how to solve for missing angles when we have parallel lines, transversals, and triangles. To understand angle relationships, we first have to understand what the picture is describing. We start off by drawing two parallel lines. Parallel lines are two lines that are separated but going in the same direction. These lines create a bit of a tunnel. A transversal line is the line that will cut through both of them, which is represented by that line there. When we're looking for exterior angles, the word exterior refers to the outside angles. So these are our exterior angles on the outside of the tunnel created by the parallel lines. When we're talking about interior angles, we're talking about angles on the inside of the parallel lines or the inside of our tunnel. So these are our interior angles. In the next slide, we'll talk about the relationships. The first relationship is called alternate interior angles. I will shorten this to alt interior for our examples. When we're talking about alternate interior, the word alternate means opposite and interior means inside. So we are talking about angles that are on the inside of the tunnel, but on opposite sides of the transversal. So in the interior angle, if I'm looking at angle number 3, the opposite interior angle is angle 6. And you can see that the sizes of these two angles are the same. 3 is a large angle, 6 is a large angle. So 3 and 6 are equal or congruent, means they are the same size. So alternate means they're on opposite sides of the transversal. Interior means they are on the inside. Also, we have two other interior alternate angles, angle number 4 and angle number 5. Opposite sides, but the same size. When talking about the exterior angles, we follow the same logic. Alternate means opposite sides of the transversal. Exterior means they are on the outside. So if we're looking at the outside angle, angle 1, the one that's on the opposite side of the transversal would be angle 8. These are alternate exterior angles. And same with angle 2 and angle 7. Again, alternate exterior angles are equal or congruent. So whatever angle is angle 2, however many degrees that is, angle 7 will be the same. Whatever degree angle 1 is, angle 8 will be the same. The next angle relationship that we are going to talk about is co-interior angles. Again, the word interior means we're looking on the inside, and this prefix co means that they are on the same side of the transversal. So looking on the inside of our tunnel, if I'm focusing in on angle 3, the angle that is on the inside and the same side as the transversal is angle 5. These are co-interior, together on the same side. Same thing with angle 4 and angle 6. They are together on the same side. Now you'll notice that these now co-interior angles are not the same shape. Angle 3 is big, angle 5 is small. Same with angle 4 and 6. When we're looking at co-interior angles, we are looking at angles that are actually supplementary. Means they are not the same size, but if you add them together, you will always get 180 degrees. Same with angle 4 and 6. Oh, I see a typo here. Angle 4 plus angle 6 is going to give you 180 degrees. We have a similar relationship with co-exterior angles, meaning they're on the outside, but they're on the same side of the transversal. So here, I'm focusing on my outside angles. Angle 1 is on the left side of the transversal. Angle 7 is on the left side of the transversal. When I put them together, they're going to be supplementary angles. That means angle 1 plus angle 7 is 180 degrees. Same with the other side. If I look at the right side of the transversal, angle 2 and angle 8, they are not the same angle, but if I put them together, they will give me 180 degrees. So they are supplementary. The next relationship is called corresponding angles. And corresponding angles is where we are comparing the 4 angles on the top line with the 4 angles on the bottom line. Corresponding angles are the ones that are in the same position. So if I'm looking at angle 1, that is the top left corner, it is corresponding to angle 5 because it is also in the top left corner. 2 different boxes created by the 2 different lines. Corresponding means they are in the same position. So angle 2 and 6 are corresponding. Angle 3 and 7 are corresponding. And angle 4 and 8 are corresponding. Because we have parallel lines going in the same direction, all corresponding angles are going to be equal to each other. Our last relationship is vertically opposite angles. Vertically opposite angles is where we have 2 angles that are opposite a crisscross or an intersection. So here we have 2 lines that are crossing over. Vertically opposite means that they are facing each other. So 2 and 3 are vertically opposite angles. Also, 1 and 4 are vertically opposite angles. In the bottom line, we have another intersection, 2 lines crossing over. So vertically opposite means they are opposite each other. 6 and 7 are vertically opposite. 5 and 8 are vertically opposite. So anytime we have a crisscross or an intersection, the angles that are opposite each other are going to be congruent or equal. So these are going to equal each other. Thank you for watching the definitions of angle relationships. Click on the next video to see examples of how to solve for an unknown angle using these relationships.